Hello everyone. We're going to be solving differential equations today. So the first thing is, what is a differential equation? A differential equation is an equation which has derivatives, it has trigonometric functions, it has polynomials, it has higher order differentials like y double prime, y cubes, logarithms, exponentials. That's what basically a differential equation is. So let's look at some of the examples. The first one is dy by dx equals y squared times sine x. So we have a differential here, which is given by dy by dx. Now let's look at the second one. We have f prime of x equals 2x minus 9. Recall, your f prime of x is nothing but y prime, or it is the same as writing dy by dx. Remember, when you say y is a function of x, it all goes back over here. So y is a function of x. If I take the differential of y, a simpler way of writing it is y prime equals a differential of fx, which is f prime of x. Now, if I take further derivative of this function, I will get y double prime, which is nothing but this d2y over dx squared. It's a differential of a differentials. So that's where we're going to look at the third example. So we have y prime plus 4y double prime equals y. So the next thing we are going to be looking at is when we say solve a differential equation, what do we really mean? What this simply says is, can you find an explicit expression of y in terms of x? So let's look at with the help of an example first. We would like to show that this y given by 1 over 1 plus cosine x is a solution to this differential equation. What simply it means is, substitute y, this y here, in this expression. Let me write it down. Substitute y equals 1 over 1 plus cosine x in this differential equation. So for that, what we're going to do is we're going to do a left-hand side. We're going to prove a left-hand side equals a right-hand side. Okay, let's look at the right-hand side. It's much more easy here. So let's look at the right-hand side first. So right-hand side is given by y squared times sine x. We are already given y. So what is y? Replace that and you write 1 plus cosine x the whole square times sine x, which is nothing but what? Sine x over 1 plus cosine x the whole square. Okay, now let's look at the left-hand side. Remember, the thing we have to prove is that the left-hand side equals the right-hand side. The left-hand side is dy by dx. So we're looking at dy by dx. And that means differential of 1 over 1 plus cosine x. Let's just rearrange this expression and write this as d dx of 1 plus cosine x to the power minus 1. And we can apply the chain rule now. So chain rule means you first take the differential of the outside, which is minus 1 times 1 plus cosine x. Now remember, it's minus 1 minus 1. That's how it's a little different than the integrals. We're doing differentials here, that's why. Minus 1 times, you're going to take the differential of the inside term, which is given by 1 plus cosine x. What do we see? Minus 1 times 1 plus cosine x to the power negative 2 times differential of 1 is 0 minus plus differential of cosine x is a minus sine x minus sine x. Okay, what do we see? From here we have, so we can just, let's write it down from the beginning. It's -1 times 1 plus cosine x to the power -2 times, this is 0 plus minus, that means minus sine x. Now simple algebra. Minus with the minus is a positive, and we will now have 1 plus cosine x minus 2 times sine x. Now we're going to take the negative power down. So we have now sine x over 1 plus cosine x the whole square. Notice this is the same as your right hand side. Do you see that? So the left hand side is the same as your right hand side. Hence we have proved that y equals 1 over 1 plus cosine x is the solution to a differential equation. Now here we were already given a solution and we just had to prove it. We'd like to look at another kind of a problem where we're given a differential equation and says find its solution. So that's the next example we'll be looking at. Okay, so this is the problem. It says solve this differential equation, or it means says find the general solution of this differential equation. Here's our differential equation, guys. F prime of x equals 2x plus 1. Now, keep in mind that f of x is the same as integral of f prime of x dx. Remember, the integrals and the differentials, they cancel out each other. Okay, so what I'm going to do is I'm going to integrate this equation. Let me write it down. F prime of x equals 2x plus 1. So integrating the above equation, which basically means f prime of x dx equals integral of 2x plus 1 dx. Remember, we have to keep the same variables. Now the differential and the integrals cancel out and we get fx on the left hand side of the equal sign. And here is the normal differential integrals we're going to do on the right hand side. So integral of 2x is what? 2 is a constant. Apply the power rule of integrals. Integral of a constant is simply x. And then, which we can just clean it up. So this 2 and this 2 cancels out. It is x squared plus x. Remember what's the final answer? The final answer always put a c. So it's going to be x squared plus x plus a c. So we have found a solution to this differential equation. Now this c is a constant of integration, so it can be any value. So whenever you have a solution to a differential equation in this form, we call this solution a general solution to a differential equation. So next one is we're going to look at a particular solution. A particular solution means can we get a particular value for c? So that's the next one. We're going to continue with the same problem. So let's look at this problem. Now we're going to obtain a specific value, as I said, of a constant. And as we are able to get that value, we will be able to solve this differential equation. And when we solve this, this is going to give us a particular solution. Okay, so let's look at this one. We just solved f prime of x equals 2x plus 1. Now here, f of 2 equals 3. So this is the condition which is given to us. So from our previous examples, we know that the solution to this one is fx equals x squared plus x plus c. Just before this one we did it, guys. Now we want to find c for that. So when you find the c over here, that means we're just basically substituting. So this means when your x is 2, your function value is 3. So just replace that. So 3 is f of 2. Now replace on the right hand side of this equal sign wherever the x is by 2. 2 squared plus 2 plus c, which we get is a 6 plus c, and the 3 on the left. So your c is a minus. Minus 9 we get over here. Oh, hold on, what I'm doing. Yeah. So minus 3, I'm sorry, not minus 9, minus 3. Because you take this on this side. So when you take the 6 here, you get a minus 3. Okay. So what is the solution now? Our solution here is x squared plus x minus 3. Notice, this is a very specific solution to this differential equation because of this condition. So this solution, fx, is called a particular solution of the given differential equation. Okay, continuing further, let's look at an application of these differential equations. They are very much seen, guys, in the biological field or in the field of population, sociology kind of things, where you're looking at how the population is growing and stuff like that. So this is a biological problem we're looking at. So let's read the problem. The rate of growth dp over dt of a population of bacteria is proportional to the square root of t, where p is the population size and t is the time in days. In other words, we're saying dp over dt is k times square root of t. That's what this whole sentence means to us. We're also given that the initial size of the population is 500, and after 1 day, the population has grown to be 600. We like to estimate this population after 7 days. Things to keep in mind, when I say P is a population, this P, guys, is a function of time because this is related to a word problem. This is a population of bacteria which is changing over a period of time. So this P is a function of time. Now, as what we are given is, we are given that the rate of growth of this population is proportional to the square root of the t. So it's the proportional. So this, when you say it, is the word proportional. What it interprets is this. Okay, let me just show you here, guys. It means dp over dt is proportional to square root of t. That's what it simply means. And then when you write it down and remove this remove the proportionality, that's what it means. So this is dp over dt is k times square root of t. So this is the problem. And we want to find the population after 7 days. We have to basically find P first. Okay, so let's do the math now. So we are given is dp over dt. Let's write down before I solve, or let me write it on everything which is given to us. dp over dt is k times square root of t. And then we're also given that the initial size of the population is 500. What does that mean? It means P of 0. That means, because remember, P is the population of the bacteria. When time is 0, that's P0 is 500. And when after 1 day, that means when time is 1, the population grows to be 600. The question says, find the population after 7 days. That's what our question is. Now, to find this population after 7 days, we have to first find, so what we have to do is first we find P of t, guys. Okay. We need to find, as I said, P of t. Okay, let's go ahead. Look at this problem. dp over dt equals k times square root of t. We're going to integrate. Remember, integrating means what? The differentials and the integrals, they are actually cancel out each other. So this simply means this. dp over dt, okay, equals, this is dt, equals k square root of t dt. Now that cancels out, d with it, this cancels out. So what you're getting is p. Now remember, this p is the integral of k square root of t dt. Now this p, guys, is this p. Keep this in mind. Now we're just going to take the integral. K is a constant, it goes out. Integral of square root of t is what? T to the power half dt. Okay. So when you solve this one, is k times t half plus 1, which is 3 halves, plus a c. Okay, let's write it down first. What have we got? We have got is P of t equals, remember this is P I'm talking about, okay? K times t, now half plus 1, 3 halves, over 3 halves plus c. Clean it up a little bit, so you get 2/3 k times t, 3 halves plus c. Okay, now this is a general solution because you have constants. Now there are two constants, a k and a c. To find the population after 7 days, we need to get values for k and c. As there are two constants, we need two conditions. And remember, from the problem, we are given that the initial size is 500, and after 1 day, the population becomes 600. So we're going to plug these values over here, okay? So once again, keep in mind, we are given that P of 0 is 500 and P of 1 is 600. You're going to plug these values to get the values for the problem. So let's go ahead, plug in P of 0. So when I say P of 0 is 500, what does that mean? Plugging it over here, so T is 0, so this is anything to the power 0 is a 0. So we get 500 equals C. So my equation now, P of t is 2/3 k times t, 3 halves plus 500. Remember, we have to get the value for k. Now we take the second condition, P of 1 is 600. Okay, so 600 equals P of 1 equals 2/3 times t is 1 to the power 3 halves plus 500. Okay. Sorry, k I forgot. K, t is 1 here, so k here. Let me write this k here. So what do we get? That 600 equals 2/3 times k plus 500. Solving, we get 100 equals 2/3 k, or 300 over 2 equals k, or k is 150. So our P of t, guys, is now 2/3, k is 150, t to the power 3/2 plus 500, which basically is now 100 t to the power 3/2 plus 500. So we've been able to get P of t with all the proper terms here. So this is the particular solution, guys, keep in mind. Now we want to find, the question is find the population after 7 days. So when you plug it in over here, we're going to estimate the population. So our estimation is around 2352. Okay, so we have solved our problem from biology. Let's look at some problems from physics. Okay, now here a baseball is thrown upwards from a height of 2 meters with an initial velocity of 10 meters per second. We would like to find the maximum height this baseball can go. Okay, so think of this one. Just make a little, I like to make some little graphs and stuff. So here is, a person is standing here. So this is, suppose a person is here. Okay, and he throws a ball. So let's look at this one. So here's this, I'm sorry, let me make this one. Here's a person. He throws the ball. So this is when he throws the ball, and here's the ground. Okay. So in the height by which he throws the ball, this height is 2 meters. So the ball is thrown. So this is a ball, guys, which has been thrown. And it is thrown with the velocity of 10 meters per second. If you recall something from your physics, we all know that velocity is nothing but rate of change of the distance. So this is given by ds over dt, where your s is the distance. Okay, so these are the things we kind of know. So now this s, guys, also keep in mind is in terms of time. After some time we have covered a distance, so s is a function of time. Now we can also write this as s prime of t. Many ways of writing it down. Remember, as I said, this velocity, this is velocity, guys. Now we are given the velocity is 10 meters per second. Okay, so what is the problem saying is it is thrown upward from a height of 2 meters. So what basically this means, at time 0, the height is 2. The velocity is, the height is 2 meters. And this initial velocity, it simply means that s prime of 0 is 10. Okay, so we want to find the maximum height. So as we said, we're looking at height means distance, okay? So back to our problem, we all know that the gravity which acts on the earth is given by acceleration. This acceleration is nothing but gravity, which is given to be 9.8 meters per second square. Now, the acceleration, which is the gravity, actually is s double prime of t. Basically, it is the differential of the velocity. This is dv over dt, which is d square s over dt square. Okay, So we know that the acceleration is negative 9.8. So s double prime of t is minus 9.8. We want to find the maximum height, guys. Okay, so let's go ahead and solve this. The first thing is we're going to find s of t. So we're going to be integrating. So this, when you integrate, that means s double prime of t is going to be what? And to integrate, so basically you are doing d2 s over dt squared times dt, which you are basically going to get is the you are going to get s prime of t. So when you integrate, you get one less here, guys. This integral cancels out with 1d. You get is ds over dt. So let's go back here. So s prime of t, which is negative 9.8. So when you take the integrals, that's what I'm just doing. So this, when I take the integrals here, that means basically integration. I'm getting s prime of t equals negative 9.8 dt. So when we solve it, it is minus 9.8 t plus c1. Now, remember, we have to find c1. c1 is the constant velocity. What is given to us? That s prime of 0 is 10. So when we substitute it over here, we get that s prime of 0, which is 10, equals c1. So, therefore, s prime of t is minus 9.8 t plus 10. Now we go ahead and do the second, take another integrals here. So integrating once again here, when we integrate, it means integral of s prime of t dt. Which is integral of minus 9.8 t plus 10 dt. Now the integral and the differential cancel out. What are we left with is simply an s of t, which is minus 9.8 t squared over 2 plus 10t plus c2. Now remember, we've got to solve for s2. What are we given? We're given that s of 0 is 2. So plugging it over here, what do we get? So we get s of 0 equals 2 equals, on this side when you plug in the t to be 0, everything is 0 except c2. So my c2 is 2. So what's s of t? S of t is minus 9.8 t squared by 2, which basically is now minus 4.9. So just write that. Minus 4.9 t squared plus 10t plus 2. So this is our distance. Now we want to find the maximum height. That's a question. Question says, determine the maximum height. Maximum height, remember, if you throw a ball. When you throw a ball, the maximum height is where, after which the ball falls down. Remember, this is when the ball is going up, this is the ball. So when it goes up, after a certain time, it's going to fall down. So the point where it reaches the maximum height, so remember this is where your ball is. Suppose this is where the ball was thrown. So if I take the xy plane, that's my ground, which is basically my x and y, and this is 2. So if I'm throwing a ball, that's where the ball was thrown, it will reach a height, and after that it will fall down. And if you recall what happens, this line is basically where the differential is 0. So the maximum height, to find the maximum height, you like to know where is the time when it is going to be, the differential is going to be 0. So for maximum height, you know S prime of t is 0. Now what was our S prime of t? S prime of t is this. Minus 9.8t plus 10 is 0. Solving this, we get t to be 10 over 9.8. Now remember, we want to find the maximum height over here, the height here, okay? And you can apply your differentials, the first derivative test, and that this is where you will see it is the maximum height. So remember, maximum height, you apply the first derivative test, or you can also apply the second derivative test. You can see that. Let's apply the second derivative because this is when you put the critical numbers, if you remember that, guys. You can apply the second derivative. Now remember, this one gives me your critical numbers, and then you need to apply the second derivative test, or in the second derivative test you plug in S prime of 10 over 9.8. If you get to be, what is it, S double prime of t, guys, is minus 9.8 here. So it's a negative number. So by second derivative test, definitely we see that this is where the maximum height occurs. So what we see over here is that the maximum height happens when t is 10 over 9.8. Now the question is, find the maximum height. So what is the maximum height? The maximum height is S of t evaluated at t equals 10 over 9.8. Now recall that S of t is what? Is minus 4.9 t squared plus 10t plus 2. So when you plug in t of which is given by 10 over 9.8, so that high S when plugged by 10 over 9.8 roughly is around 7.1 meters. Yeah, it took a long time, but guys, we have the answer. So this is the maximum height. And the maximum height happens when time is 10 over 9.8 seconds. Remember, we're talking in meters per second. Okay. Yes, it took a long time. Look at this one. This whole to solve this problem. Now, I would like you guys to practice these two problems so that you are able to make some understanding and know how to solve or apply differential equations and solving them in applications. Thank you.